first one that I want to do here is that I want to talk about air helmets. For bicycles. So I have a video that I want to show you. Let me go set this up. Okay, I'm ready to go. So let me go share my screen with you. And this is an air helmet that was designed. I can't remember where it was designed. It was somewhere in Northern Europe. And I want to say it was either Amsterdam or Norway or Finland or something. And there was two women designers that ride their bikes to work, and they actually didn't want to mess up their hair by putting on a helmet. So they got together with some person who helped design it. I believe it was an engineer, and they came up with this really, really clever idea. Check this out. Okay. So I'll start it and stop it, but I'll play this a little bit so that you can actually see what I'm talking about. Here we go.
Ready to do one for now? We've covered the Hofting airbag for cyclists on Bike Radar before.
Look at that.
We've come down to Bristol's Mud Dock today to see it work in action. I'm joined by John from Hofting UK, and we're going to talk a little bit about this.
So here's another angle of it in slow motion here.
So, John, first of all, can you tell us where the product originates from and how it's come to be in the UK?
It was developed in Sweden. It came to
also Sweden, and so you can see it's almost like a. It's almost, that's the way it looks right there. So it wouldn't mess up people's hair unless, you know, it inflated, which of course you would want that. But that is a genius idea. And so when you're looking at this image here, right? I hear that these helmets are pretty pricey. I was actually going to price them out, but I mean, let's look at this thing here. So what I'm going to do here is I'm going to go back and share my screen with you. And you could see there's the air helmet right there. And what we found here is that we found what? Well, what does the air helmet do? Follow the flow chart. So when I look at the air helmet, why is the air helmet really good? Because what does it do? It increases contact time. In other words, I'm going to have a large contact time. Now remember, we got to follow the flow chart. I got the contact time. So now what do I got to know? I need to know about the acceleration. So in this case, because I have a big contact time, I'm going to have a small acceleration. And as a consequence, then Newton's second law tells me what? That a small acceleration then is going to give me a small net force. So what does that mean? That the rider feels less because of that contact time. We could say the same thing with, right? Why is it safe, right? For a boxing glove, I wouldn't say that it's safe, but we'll leave it there. Boxing glove versus bare fist. Which one's more dangerous? Bare fists. And we follow the same kind of thinking. So when I think about the boxing glove, oops, that's not the way you spell boxing. When I look at the boxing glove, what's it going to do? It's going to do what? It's going to increase the contact time. As a consequence, then the velocity, excuse me, the acceleration is going to be tiny. And therefore, you then have what? You have a small mass times acceleration. So you get a small net force acting on you, a smaller net force acting on you. But if you're bare-fisted, that's a whole different ballgame. Why? Because the contact time is small. And at the small contact time, then that tells you here that this guy is going to do what? Well, it's going to give you a huge acceleration. In this case, it's a huge deceleration. And as a consequence, then you're going to feel what? A huge net force. So in this case, you feel less. Here, you feel more. That's what I mean by that. Another very, very common thing that people look at is jumping off a table onto the ground. So what happens when we look at this situation? So imagine that we have a table. And of course, this table is elevated. And of course, we have the ground here. So when I'm looking at this table, what we're going to do here is that we're going to look at people jumping off two situations here. So I'm going to imagine that I have this situation, and then I'm going to have a different situation over here. So what I want to do here is that I sort of like want to analyze the situation. So you could imagine, here's a person in blue, and their whole goal is to jump. Here, I have the exact same person in green. And what they're going to do in each of these situations, they're going to jump. Now, you know that when you jump and you're going to land, one of the very first things that people do is that they do what? They bend their knees when landing. So then this person in blue does what? What they do here is that people bend their knees when landing. And the question is, why? Why do these people bend their knees? Well, let's go through it. If you bend your knees, what happens? You increase contact time. And if you increase contact time, you have what? You have a smaller acceleration. And if you have a smaller acceleration, you have a smaller F net. So what happens? This is what we say that you feel less, but many a times people call this a soft landing. By the way, if you have a soft pillow, or if you have a soft blanket, this is the reason why. It's about Newton's second law. Now, let's look at this idiot over here. This idiot in green is going to do what? When he jumps, this idiot here does what? He locks his knees upon landing. What does that mean? Well, according to Newton's second law, he locked the knees. So what does it do? It not only, it didn't increase, it dramatically decreases the contact time. And because of the sudden, stop here, you get a large deceleration. And therefore, you feel a larger net force. So now, what we say here is that in this case, what do? You feel more. And a lot of times people will say, this is a hard landing. Well, if you did that, I'll tell you this much. You jump off of a regular table height, I suspect that we would be calling 911 to come and pick you up because you just busted your knees. You just did a whole bunch of damage. Now, I'm going to tell you what happens in Physics 10. What people do here is they do the following thing. What they say here is they'll go like, oh, my knees absorb. Instead of saying increased contact time, smaller acceleration, smaller net force, they're going to say, oh, the knees absorb, or the body absorbs it. I'm going to tell you right now, I'm going to give you 0. That has nothing to do with physics. And it's wrong. It does not absorb it. And so you need to be careful with the language. This is a physics class, so I expect you to talk about physics here. And there's lots of other examples that we could think about. I mean, just think about an airbag versus no airbag. I mean, what's the difference here? If you have an airbag, you can clearly see here is that if an airbag deploys and you hit the airbag, it's going to increase the contact time. Therefore, you have a smaller deceleration. Therefore, you're going to feel less. Yeah, people are saying like, hey, airbags are really dangerous, right? They can cause burns. They can cause bruising on the face. I agree. What's the alternative? The alternative is that if you don't have an airbag that deploys, look what's going to stop you. The steering wheel on your upper body, and then on your mid body, and then your face is either going to stop by the dashboard or the windshield. In that case, Newton's second law is real clear. You have an extremely short contact time, an enormous deceleration, and oh boy, you're going to feel more without any doubt. So what do I think? I think airbags are important.